Here I am presenting a multi-agent data-coupled approach to a process-first landscape design for resilience. Our work asks, how can we design like and with beavers? This work is done in collaboration with the Harvard Graduate School of Design, Technion, Israel Institute of Technology, and Woods Hole Oceanographic Institute. This work is inspired by and focuses on the North American beaver. Beavers famously build dams, but they build more than just dams. They excavate ponds, making them wider and deeper. They excavate canal systems to access terrestrial and aquatic resources. The beavers live in lodges. They also clear extensive forage networks over land. They build food caches to survive during the winter, and they are highly territorial and build scent mounds to delineate their territory. All of these features come together to build a beaver damming complex. A beaver damming complex is many times larger than any individual beaver and takes generations of beavers to build. A beaver damming complex also shows a huge variety of morphologies from across the world. These damming complexes are also dynamic, going through periods of expansion and contraction. This work in particular focuses upon beaver trails and beaver canals. This work hypothesizes that productive beaver trails are gradually reinforced into canals, forming an interconnected hydraulic network over 50 to 75 years. To understand beaver trail morphology, we look to the structure of neurons forming memories. We must consider the landscape as a computational substrate and the trails and canals as forms of memory that individual beavers can tap into, reinforce, and ramify if productive, or abandon if there are no resources. Much like neurogenesis for neurons, beaver trail neurogenesis take on different morphologies as well, where homogeneous environments, those defined by a near constant vegetation gradient, have a loopy branching network, a bit like a cauliflower, where environments that are scattered with high quality vegetation are more dendritic with firmer branches connecting to vegetation resources. The third type of canal is connecting along the lines of water. When beaver agents in red have simple rules. When on water, dig. When not on water, find water. The water agents follow a gradient of a digital elevation map of a real-world site. We let this run over a series of several years, and we can see a footprint very similar to what we see in satellite imagery of a beaver damming complex. We are also testing our hypothesis about beaver behavior in the field. Here shown is an excavated human-made canal with a camera trap. It seems if you dig a canal, a beaver will come, allowing us to design like and with beavers.